All right, so today we're going to talk about real-time product observability with Statsig. So I'm going to talk a bit with Druid and then our kind of entire journey with Druid. A little bit about me. My name is Jason. I work at Statsig, mostly work on infra. I used to work at Google, and I worked on Kubernetes, and it's still open source. So Druid, all this stuff is like open source. It's very exciting to me. So that's why I'm kind of very into it, kind of trying to work with the community and help Statsig also use it. And we have Rivik, who also contributed to the slides, also our product. But he couldn't be here. But you saw his profile there. Awesome. So about us. So Statsig. So we are a modern and trusted experimentation platform. So we help customers run experiments on our platform, and then these experiments help them identify features that causing like their metrics to move, right? So we were started by like a bunch of ex-Facebook engineers and product managers. So we started. We were inspired by like internal tools at Facebook. If you heard about them, like Deltoid, Scuba, and all that, right? We kind of inspired by that, and we want to kind of create this community also about like experimentation and A/B testing. We started pretty like recently, like actually started February 2021, and then we're just still a little over 1 year, and we started in Kirkland, and now we're based in Bellevue, and we're now a Series B company, and we're backed by Sequoia. Currently, some of our customers, we have 600-ish customers, and some of those are Notion, Lime, and Ancestry, they're all running on our platform with their like experimentation, A/B testing, and using that day to day. Excuse me. So the reason that we create Statsig is actually we want to kind of bring what we learned from these large companies about the experimentation culture, about A/B testing culture. Like we want to bring that to the community and influence other people to use this kind of product development kind of culture to also foster their own products. And we want to kind of people have this kind of mindset that data is their kind of foundation of their growth, right? So you always like use data-driven approach to decide what you do next and what you want to build next if your feature is built correctly, right? And also we want to kind of empower the engineering teams and product teams to just hands-free on the kind of the data side and instrumentation side. They just care about like what they build. Basically, we want to kind of help them use data to gain insights, but we want to do that through the term we call product observability. So in a traditional kind of landscape, you would think product analytics is kind of people build something, and then the product team ship something, and then they have features, and then once that, they track the metrics, and then once it's built, then they look at, oh, what's the end result? And let's see, oh, that works. Oh, that's great. If not works, let's try to figure out what's going on behind the scene, and then make a little guess and see what's going on there, and iterate. Hopefully, the next round will get it better, right? But with product observability, you not only get what you get the end result, but also you get the whole picture, and then throughout your product development lifecycle, you get all these metrics, not only just metrics, but also insights of what you are building. Is that right for the customers that you are serving? Is that run, or you kind of being kind of adaptive approach to that and learn from your customer and your user in real time, right? So that's what we want to kind of build with Statsig and to provide that observability kind of functionality to our users. So to sum up, like product observability is more than product analytics and not also beyond monitoring, right? Like it's a proactive and continuously adaptive approach to build and measure your impact and use data to learn what you built, right? So let's use an example for that. So let's say we're building a retail shop that just sells like toy airplanes, right? So we want to test out, like on our website, these types of product images, like which one work better. So on the left side, you have like rounded squares, and then circles, and then squares. So now you come to Statsig, and then with this dashboard, like you can set up your experimentation, and then you define, like the primary metrics that I care about. Like you can see there, like purchase event, like add to cart, product view, and total purchase, and all that. And then you start running your experiment, right? Like you ingest your event, you send your events to Statsig, and then start running these experiments, and you can see like how those events are, how those features are being exposed. And then after some time, you will see this kind of like insights, right? Like basically it tells you, like in add to cart, like circle is performing better than square, and you get like for each one of these metrics, you get the results. And then the green ones are what we call like statistical significant ones, right? So that's where our name comes from, like Statsig. And then you make that decision and say, circle is doing better in our real users and than squares. Then I might just ship with circle. And then the following metrics also kind of back that up, right? So this is kind of the experimentation view, right? Like also you can do the similar things on Statsig with like feature gates or feature gates. Once you gate a feature, you also have, like we also provide this analytics to you and help you decide whether your gates is working well or not, right? Like, and also like we have auto-tune that helps you auto experiments, like kind of gradually shift your traffic, like your users to the ones that's performing better, right? So all that features. But one thing that we also often get asked from customers is actually, like, this is great, but this is basically, I put data in, and then I set up my experimentation, but then I just wait and hopeful something comes up, and then I will get a result. People really want to do something before that, right? Like, there's still gaps between like when we actually run experiments and when I actually got results. So there's questions from, like, say, engineering team. They ask, is my instrument correct, right? Like, did I set up everything correctly in my code and then roll it out? Did the rollouts ratio correct? Also from the product team, they're asking, can I see, like, with the current user, can I get a breakdown of their age, where they're from, all their metadata, right? Like, and then data science team, they want to understand, can I early validate some data, like just to run some preliminary queries against my like real-time data and validate some results, right? So those are some asks from our customers, and that's why we built this feature called Event Explorer, right? Event Explorer basically, on top of experimentation that we provide and metrics that you collect, Event Explorer basically allow users to analyze their data in real time, right? So it's very useful. The way we see it, like people are using Event Explorer to diagnose their kind of new issues that they're seeing, and then they just want to dive into that real time and see what's going on, right? And then like kind of provide also Event Explorer provides that interactiveness to your data and then explore it a little more, right? Like, so kind of trying to fill those gaps, right? So here's some kind of screenshots that we have, like basically powered by Druid, that we're able to provide time series queries, this one, and we're able to provide aggregation, and then just provide a view of the raw events that's sending to us, and people can just scroll through that and provide certain filters. Speaking of that, then I will just kind of dive into like kind of our architecture a little bit and our journey with Druid. So this is kind of our old architecture, like which is also true for today. That our customers, like they use like Statsig API, and then they send like events to Statsig, and then we process that data into a data lake, and then those like jobs being run daily, hourly, and then being processed in Databricks and then stored into MongoDB. basically that's how like our experimentation is run and processed. And then with Event Explorer, we add a layer. Basically, we add Event Hub in the middle, which provides kind of data streaming for us. And then the data is streamed both into the data lake and also streamed into Druid. And then Druid provides this kind of REST API and that we can use to provide, like, kind of show that on the console. Very straightforward kind of architecture, like what Darren was describing. So before I dive into like why we choose Druid, just a little refresher. I think Darren covered this mostly, but just to run that quickly, like master servers, those are kind of like basically running, like overseeing your job, and then where the data is, kind of mastering all that, right? Like query servers are the ones that actually does the queries, like process the queries for you, and the data servers basically they store the data and process the ingestion, all that. Like they're the big servers, and the orange box are the kind of the other services that you need to support to Druid. So why we choose Druid in the first place? So I think I would like to break that down into three pieces. One is easy onboarding. So easy onboarding. So we started. I think Jay also mentioned like that we started with Druid like very like recently. We started like around like April or May time-ish, and then we were just testing out like what would best serve our customers with the Event Explorer. What would best to kind of back that up, right? And then we were just testing a few other solutions, and then Druid stood out because it was quick to install and very quick to test. Like we basically within one day, like spin up a Kubernetes cluster for us, and then just to run Druid on it, and it just works fine. Like very, very great. Although like some of the parameters are still like in the test environment, they are like just for demo purpose, but still like it serves great purpose for that. So we kind of went ahead beyond that. So I would say like this is like people. Oftentimes, like we hear that like people are intimidated by like the microservices architecture of Druid, but in reality, like this is actually like there's a lot of support around the raw Druid kind of distribution, and this is actually pretty easy to run in our experience too in test and in production. Community support, I would also kind of second to what Darren was mentioning, is like the support of the community is super great. Like you often get answers like very quickly, like within like a minute or so too, like from a community member. I don't know, like probably someone is always monitoring the Slack channel or something. so yeah. And documentation. Documentation of Druid is actually a ton of content, but once you kind of try to start to study about it and understand the details about it, the documentation is actually very detailed and very great. Like you basically can follow documentation step by step, and then like finish your task. Flexibility, I think that kind of goes back to the microservice kind of architecture. That's kind of provides a little flexibility on how we manage the components. So like these components, individual components can scale up and scale down individually without affecting the other components. So that's the reason why it's like kind of almost no downtime. And then we actually on our background, like we do monitor our operations, but we do see sometimes like because of different reasons, like a region or even like a availability zone goes down or something, like we see our VMs go down, and then we're able to still get Druid up. And we're able to do like gradual changes, upgrades, so that's also possible. Like that's all behind the scene, right? And fast here I mean like for integration is pretty fast. There are a lot of integration support. We use Azure, so a lot of these are like kind of integration with Azure, especially with Kafka. Like we use Events Hub, and then Azure Blob Store, and then the SQL support, which a lot of our data scientists and also our engineers are like familiar with. So their like integration is good for them. Ingestion and query, like what Darren mentioned, like these are like fast kind of for per ingestion. Basically, you hook up your stream and then your data is going in. You don't need to wait, or you don't need to actually do any extra processing, and then it's there. Query, of course, is sub-seconds queries. I would like to go through a few learnings that we learned from like running Druid. Some may kind of be helpful for you when you actually want to start with Druid. And of course, these are like, we only ran like Druid in production like for like 2-3 months. But something like we would like to share with the community. Definitely we'll learn more and then we'll have more to share. So first of all, we run Kubernetes and GitOps. So we run Druid cluster on Kubernetes. Can I get a show of hands, like how many people run their workloads in Kubernetes here? Okay, I think that's the kind of the trend these days. So Druid originally, I think, original support was on just raw VMs or kind of, right? And recently, I think there's, during each release, they provide kind of Docker images, and also I believe Imply also provides their own images. So the Kubernetes support is actually getting better and better. So the benefit of running in Kubernetes cluster is actually you get very flexible pod size. Like when you actually start using Druid and try to provision Druid, you really don't know how much you need, right? Like with a VM, then you basically you need, oh, I need to provision a VM and wait for some time and then try out. If it doesn't work, I kill the VM and then spin up a new one. But with Kubernetes, you really can define that in Kubernetes context, right? Like you can define how much, let's say like at the beginning, I will probably need a smaller, in testing, I need a like smaller data nodes, then I just provision like smaller ones and just test it out, right? Like those are very flexible. Even in production these days, like we still kind of change our kind of pod size a little bit to meet our like usage, right? So I think that's one big benefit. Just a rundown of like kind of nodes that we use. Master nodes, we use Azure like D series, which is like kind of the general compute series. Like you can pretty cheap on Azure. Data nodes, we used to use D, and then we kind of migrating that to L, which is more like high performance kind of series, which to just kind of bring up the performance a little better. Query nodes, the F series. F series is just like similar to D, but it's just a more CPU and to memory ratio. So it's a little better for like processing queries. Deployments. So like I mentioned, like there used to not be very good support of Kubernetes kind of support in Druid community, but recently I think Helm chart became the one main thing along with the release. So you can, if you're familiar with Kubernetes, Helm basically is kind of the manifest that you can, like they package the application, and then you can basically run Helm install and deploy to Kubernetes. It's super easy. So they have that support now, and then we also use Druid operator. So operator is kind of a mode in Kubernetes where there's another kind of application manage Druid. So it has some benefits beyond like what Helm chart provides. For example, like more controlled upgrades. So you don't have to manage that yourself, right? Like, and a few other features. So that's definitely not in the Apache kind of repo, but still I think it's getting more kind of attention in the Druid community. One last thing is like GitOps. We run actually our entire fleet on GitOps. So for people who don't know GitOps before, like GitOps basically is a practice, a DevOps practice that you basically use like version control, like CI/CD, all your DevOps practice to run your infrastructure automation. So you define all your manifest, all your deployments in Git, and then you can do a bunch of stuff in Git, like your other parts of your repository, and then basically like GitOps will help you deploy to Kubernetes and manage, like you can manage through Git for that. So this is actually a great way for our kind of purpose. Like we don't have a lot of people working on Druid, but sometimes we need code reviews, collaboration. GitOps provides us a very good way for other people who may be newer to Druid to understand what you're doing and then collaborate further, so you can actually move faster instead of slower. Second learning I would like to mention is like the metric-driven approach. So we, like I mentioned, we recently started with Druid, But Druid like configuration and documentation is so large. It's like almost impossible to go through that on your first day or second day, right? So instead of like try to over provision and make Druid like great, the approach that we did to spin up Druid and bring that into production is basically a metric-driven approach. What it means is basically we don't want to try to reach the best performance of Druid that's possible out there. Like it's not for us. Like we want to reach where we think or our customers think is the best metrics, right? So for example, we define our own internal metrics for our queries, like even Explorer queries, and also we define our own kind of metrics on clusters, JVMs, segments, ingestions in query. And actually, some of these are provided out of box by Druid. So the Statsig emitter, we use that, and then we use Datadog, and then they work pretty good. And then like they provide the dashboard, and we can just monitor that. This is kind of the approach that we are still using. Basically, we are kind of evolving. Our metrics are evolving along with how our customers are using it. Yeah, this is gonna be like the way we're gonna kind of evolve. Like, yeah, because as a startup, you will have like limited resources to do unlimited things, right? So, yeah. The third learning is job scheduling. So a lot of people start with kind of using Druid, just using the UI, and think, oh, I just want to create a job and then just start running there, and then I don't have other choice. But actually, Druid has a pretty good support for its API, not only just the query API, but also the management API. And we actually use that for our sub-real-time ingestion, like our metrics and aggregate metrics and experiment results. And we use Kubernetes cron again, like we're using Kubernetes for most of almost everything that we do. And cron job for scheduling those queries. Basically, we know like when our jobs are done, and then we can trigger through the REST API and configure like new jobs to run for today and another job for run the other day. Query cache. This is another thing about kind of optimization, right? So Druid can do cache, but it can do like per segment cache and also whole query cache. Per segment cache is something like it provides out of box, but it also requires some tuning from the end user. So this is something like I think we do like out of box, but like query cache is something like you will not need to understand how your users are using it. So for us, we have a lot of cache that's like people just reuse. Like for example, we share a link to our Event Explorer page, and then people send to the other folks on their team, and then the query pretty much the same. So we don't want to Druid to rerun that, right? We want Druid to just cache that and then provide that same result, right? So that's like in a lot of cases, that's what a lot of our use case. So we optimize for whole query caching on our ends, but it can be dynamic, right? Like in the future, we will have more use cases, so we'll need to kind of tune the per segment query cache a little more. Last thing I want to mention is query ID. So this is actually a pretty useful feature for us. So what query ID is basically, it's a UUID that tracks down your query throughout your entire lifecycle of like when your customers or the user sends the query, and then you can track down through when Druid process it, and then what's the response. So UUID is actually pretty useful, and then you can actually set the UUID with your query. So for example, in our Event Explorer use case, we generate a UUID for our queries, and then we send that to the Druid query context, and then Druid can use that UUID throughout its metrics, throughout its entire kind of lifecycle of the query, and then process provide you with that data. So for example, you want to troubleshoot your query, you can say basically, I have this query ID. How is it performing in like query node? How's it performing in other nodes? And what's the overall latency for that query ID the user is seeing? So you can actually hook that up with different components, even your components, and we also use that in our Statsig events. So yeah, so that's something that we use, and it's pretty useful. And then lastly, I want to talk about kind of the future of Druid at Statsig. Of course, we're still early, and a few things that we would like to kind of do as we move along. And basically, the first one is kind of rich data and more data type ingestion. So we want to kind of bring more real-time experience to our product. So so that means like we ingest more data types and more kind of data like columns, all that like into our ingestion pipeline for Druid. And also again, like bring more real-time data in all parts of the product development, including what we do internally and also what we provide to our customers. And then also flexible control of the data for the user. So right now we do actually sampling for our users when they ingest the data, but we want to have the users to have more control of the data that's sent to us, so they will be able to have more customization of what this data that's sent to us and then being stored in Druid. And lastly, like kind of data tiering and user-driven data management. Similar to that, basically, Druid can provide with a tier of data, like hot cold data, and then you can use probably like a cheaper storage for your cold data, all that, right? So that basically helps out with our cost management and also how like maybe users can ingest more data to Druid and have more control. So yeah, that's pretty much it.